I am a postdoctoral research fellow with Professor Dr. E.G. Rajan as research mentor. I am going to present one of my findings, security in Internet of Things system. Industrial IoT, that is IIoT, refers to the application of IoT technology in industrial settings, especially with respect to instrumentation and control of sensors and devices that engage cloud technologies. Recently, industries have used machine-to-machine communication to achieve wireless automation and control. But with the emergence of cloud and allied technologies such as analytics and machine learning, industries can achieve a new automation layer and with it create new revenue and business models. IIoT is sometimes called fourth wave of the industrial revolution or industry 4.0. Some of the common uses for IIoT: smart manufacturing, connected assets, smart power grids, smart cities, connected logistics, smart digital supply chains. Here we display the main components of IoT architecture in this slide. You can see this diagram. All the IoT components are internet enabled. These three initiatives are framed on certain key aspects of smart cities, to be precise, smart country. Some of them are listed below. IoT enabled corporate firming, transportation of things and peoples, farm to home distribution system, power distribution system, healthcare, security measures, and governance. IoT is implemented in three stages: implant of suitable sensors on things and allocation of addresses for them, software for sensor data collection and consolidation, data transmission. Not only in data transmission, but also control signal should be sent. This we call as control over IP, sending similar to voice over IP. Many countries have already taken initiative to implement IoT enabled infrastructure and services. The steps to be taken for the implementation of IoT are given below. Investment in the fundamental R&D plays a significant role in this context. Manufacturing of sensors for various data collection is of paramount importance. Multi-sensor fusion techniques have to be seriously looked into. Formatting of raw data using big data analytics methods ought to be studied. Machine learning techniques, training of human resources in this area is to be viewed seriously. Policy making in government and private sectors is important in integrating networks. A commercial outlook has to be given to the entire initiatives for its own survival. Applications of IoT and challenges are: diabetics may use sensor that will monitor blood glucose continuously and the reading sent to the doctor through internet. Pacemaker would be made IoT enabled and the function of the heart would be sent and monitored and sent to the healthcare professional via internet. Within few years, biometric information pertaining to human beings would be available in the network so that devices and various physical objects would warn and advise human beings for corrective measures based on the situation related biometric information. IoT connected home, otherwise also called smart home. Home automation is a decade old paradigm which will play a significant role in connecting all homes in a city and all cities in a country. Based on the current trend, users will soon be able to control all home electronics with just their phone. Studies show people are now using technology daily for longer periods than they spend sleeping, as the ability to multitask activities easily with smartphones and tablets increases. This level of remote control and access in the palm of your hand allows users to conserve energy in their home even when they are not there. A signal from a smartphone app would open the door. Homeowners can send these digital keys to friends and relatives through the app and delete them as and when required. Based on whatever discussed so far, one can think of smart cities. A smart city is an urban development vision to integrate multiple information and communication technology solution in a secure fashion to manage a city's assets. The city's assets include, but not limited to, local departments, information system, schools, libraries, transportation systems, hospitals, power plants, water supply networks, waste management, law enforcement, and other community services. The goal of building a smart city is to improve quality of life by using technology to improve the efficiency of services and meet residents' need. Through the use of sensors integrated with real-time monitoring systems, data are collected from citizens and devices, then processed and analyzed. The information and knowledge gathered are keys to tackling inefficiency. Here, then, are the top 10 smart cities on the planet: Vienna, Toronto, Paris, New York, London, and etc. The Indian government's plan of developing 100 smart cities in the country, for which rupees 7,060 crores has been allocated in the current budget, would lead to a massive and quick expansion of IoT in the country. Also, the launch of the Digital India program of the government, which aims at transforming India into digital empowered society and knowledge economy, will provide the required impetus for development of the IoT industry in the country. Future smart cities would turn out to be flexible when natural and environmental situations are also taken into account while designing IoT enabled smart cities. A decision made for the dynamics of a smart city in a particular season need not be the same for another season. Moreover, an expert system based automatic control over the dynamics of future smart cities is a wide space for researchers and city planners. If one can prevent the Internet of Things from changing the way we live and work, it will be a breakdown in security. While security considerations are not new in the factor of information technology, the attributes of many IoT implementation present new and unique security challenges. Addressing these challenges and ensuring security in IoT products and services must be a basic priority. Users need to believe that IoT devices and related data services are fixed from vulnerabilities mainly as this technology become more pervasive and integrated into our daily lives. Main challenge is the integration of security mechanisms and the user acceptance. User must feel that they control any data that is related to them rather than they feel they are being controlled by the system. This integration causes new requirements not been previously considered. Emerging trends and opportunities in the IoT are, albeit the fact that work is in progress pertaining to sensor development and big data analytics. It is far more important that fundamental research is initiated in areas like environmental engineering, prediction of natural calamities in disaster prone areas, and post calamity damage control. Manufacturing will become more efficient with better supply chain management. Healthcare will be impacted by increased patient surveillance. Agriculture will be enhanced by monitoring crops and controlling growing conditions. Our environmental data will be captured and controlled disease air pollution, and water linkages will be detected using sensor devices to name a few. Security in the current IoT is not as good as it ought to be. This topic shows some glaring flaws in existing products, which is often created because of oversight from the developers, as the constraints existing in IoT requires a more thorough thought process than is normal in desktop computing. Due to limited power, bandwidth, and processing power, everything needs to get stripped down to the bare minimum while still maintaining good security properties. Let me summarize. Security is an oversight in many projects. Using examples from previous research and conducting unique analysis on existing products, it is shown that many developers more or less ignores everything related to security or create their own cryptographic algorithms with clear flaws. To ensure that the future of IoT is secure, this topic aims to make developers think about the limitation they exist and provide solutions to the problems that will occur when designing a device for the IoT. Securing the IoT is important to custom consumers. Through previous research, it is shown exactly how devastating not focusing on the security of IoT devices can be, with the majority of consumers, that is 62%, feeling completely violated and extremely angry to the point where I would take action. Close to half, that is 48% of all consumers would hold manufacturer responsible if a flaw was to be found in the system, showing the obvious economical risk taken by not securing a device properly. Some of the topics of challenges presented are common in information security but poses new challenges because of the unique constraints. The limited power, bandwidth, and processing capabilities will require a thorough thought process to decide how to both efficiently and effectively secure a device. The other challenges are more specific to the IoT. In regular desktop computing, an advanced user interface is usually available, and physical loss of a device during use is relatively uncommon. IoT devices will, on the other hand, usually have a really limited user interfaces and will often be placed in exposed areas and used in situations with high physical stress. Security should be a consideration through the whole project. Long before the first prototype PCP design is sent to the factory, key decisions on security should have been decided. These include how keys should be distributed to each device, if hardware acceleration should be used, how updates can be handled, if a public key infrastructure is viable solution for the device, what type of cryptographic algorithms should be used, etc. Some of the future work are: the IoT is a relatively new concept in terms of optimized protocols and security, and thus there is a lot of work for the future. The most pressing issue is simplifying the use of security in IoT for developers without thorough knowledge of IT security. Designing and implementing security in protocols that is simple for developers to use is a must for the future of IoT. Speed and cryptographic strength is especially important in the Internet of Things, as devices in the IoT are constrained devices. Efficient implementations or cryptographic algorithms is especially important to keep the cryptographic strength at an acceptable level. The IoT is an ever changing area that will continue to change in the future. While the recommendations in this presentation are made with assumption for the future of IoT and encompassing many different solutions, one will have to re-examine the recommendation with large changes in the market. But thus, many cryptographic properties will always be existing and important. Most of the recommendations will be the same for all foreseeable future. Let me conclude. IoT is the future of the world order, and the Western countries have already initiated various plans and programs in this regard. As usual, India is lagging behind them, and now is the time for the country to start thinking in this direction. This is an act of togetherness and integrity, and the central and the state governments should take note of this and provide plans and facilities to various governmental and private industries. Common man should also be educated accordingly. These are all my references for my research work in this context. Finally, I thank the authorities of World Innovation Tech Expo and the Investment Summit 2023 for permitting me to present my research outcome, and especially I should thank Professor Dr. E.G. Rajan, my mentor, for giving me permission to present my research outcome in this Investment Summit 2023. Thank you for all.